Okay, welcome back to part 3 of section 9.4. So this time we're going to look at a new type of partial fraction decomposition, and that's where our denominator q of x has repeated factors. So we'll factor q of x if necessary, and that's at the point we're going to find the repeated factors. And then we're going to use a variable, again like we did last time, a, b, c, or however many we need, for the number of times there's a factor of q of x. And so then we have p of x over q of x equals a over x, the ax plus b over ax plus b squared, because each time there's a factor, you're going to have 1 here, 2 here, 3 here, all the way up. If we go to 26, then you can use all the way up to z, but usually, 2, 3, we don't go too high. All right, then we're going to multiply both sides of the equation by the LCD again to eliminate any fractions. Expand our right side, add like terms, and then we set the coefficients of like terms from the left side equal to those on the right to create a system of equations to solve. So of course, the first one they give us is going to have something factored, and then after that, we're going to have to start factoring here. So what we see is we have two factors of x minus 1. And so what that says is we're going to use the first factor and say that's going to be a over x minus 1. Then our next one is going to be a factor of b over x minus 1 squared. Okay, and so that's how we're going to first break it apart. And now we're at the stage we multiply by the LCD, which is just the x minus 1, the quantity squared. And so when we multiply the first one, we just get 6x minus 11. Multiply the next one of them cancels here, so we'll have a times x minus 1. And guess what? When we cancel here, we just get plus b. Okay. Now we distribute on this over here, so 6x minus 11 equals ax minus a plus b. And we're at the point where, okay, well, this term is like, and these terms are like, so we have two equations. We'll have 6 is equal to, and we just have that is equal to a, and then we have a negative 11 is equal to a negative a plus b. All right, so we've got a done. We don't have to do anything with that one. So what we can do is substitute it in here, and so negative 11 equals a minus 6 plus b. Add 6 to both sides. B is equal to a negative 5. And so now we've already simplified the whole question, and we're done. We have A, we have B, we can plug it back in. And so 6x minus 11 over x minus 1 squared is equal to A, which we said was 6 over x minus 1, plus B, we said was minus 5 over x minus 1, the quantity squared. And again, you can put the 5 negative up here, or you can put the negative here and make that a positive 5. Doesn't really matter, and both answers are technically correct. Okay, so that's what I would do here. All right, the next one, what are we going to do? Well, the next one, it appears we have a common term if we look here, because we have a 2 that can be pulled out of each of those. So that means we have to really factor this. So 2x squared plus 12x plus 18 equals, well, we have 2 times what's left over. Well, x squared plus 6x plus 9. Well, now this is a perfect square, so that's going to be 2 times x plus 3, the quantity squared. Aha, we've got our squared term, so we have repeat factors. And so this becomes 5x plus 14 over 2 times x plus 3, the quantity squared. And so now we'll use a for our first one. That's going to be 2 times x plus 3 plus b over the next one, which is going to be 2 over x plus 3 squared. Okay. Now we multiply that whole thing by our LCD, which is 2 times x plus 3, the quantity squared. So when we multiply the first term, guess what? We drop the whole thing in the denominator, and we just get 5x plus 14. When we multiply the next one, we drop 1, 2 on each of it, and then x plus 3 on both of it. So we have a times x plus 3. And then here, everything cancels, and then so we just get plus b. So that gives us 5x plus 14 equals ax plus 3a plus b. Now here's another case where we have a and 5, so we get a is equal to 5, and then 14 is equal to, and we get the 3a plus b, okay? Now, what we need to do is substitute that 5 in for a to solve for b. 14 equals 3 times 5 plus b. And so 3 times 5 is 15, so let's subtract 15 from both sides. And so minus 1 is equal to b. All right, so now our partial fraction decomposition is equal to a, which we said was 5, over 2 times x plus 3, plus b, which we said was negative 1, over 2 times x plus 3, the quantity squared. Okay, and so that would be where we stop. We don't have to go any further, and that's where we're done. So if we circle that, that would be your complete partial fraction decomposition. Again, if you wanted the minus here and a plus here, you could do that, but for now I'm just leaving the signs kind of where they are. All right, what about this one? Here we have a couple of things here. We've got this and we've got this. So we've got a lot of different factors here we have to consider. So when we have multiple factors, because we can see that, x squared is really just x times x. Well, what is this? Well, we factor that, it's going to be a perfect square, so that's going to be x plus 6, x plus 6. So it's x squared times x plus 6 squared. And so we've got two repeating factors, okay? And so the two repeating factors cause us to do a little bit more work. And so that gives us x cubed minus 5x squared plus 12x plus 144 all over x squared times x plus 6 squared. So we're going to have a over x, if we consider this is, number 1 and number 2. Then we have plus b over x squared plus, now we'll have a c over x plus 6. Now we'll have a d over x plus 6 squared. Okay, so now we've got all of them kind of taken care of. We have the two factors here and the two factors here. And so now we have to multiply that whole thing by x squared times x plus 6 squared. Okay. As you can see, this one's going to be a little bit longer, and I probably didn't give myself enough room on this one. So we'll have to go out and make another page. And so when we multiply that times that, that gives us x cubed minus 5x squared plus 12x plus 144 equals. Now 1x cancels out of here, so we have a times, and then we'll have x times x plus 6 squared plus b times what? Well, now the x squareds cancel, and so I have times x plus 6 squared. And then I have plus c times what? Well, now x plus 6, one of them is gone, so x squared times x plus 6, and no squared, just x plus 6. And then plus d times, and x plus 6 squares, and so that's just going to be times x squared. All right. Well, now we kind of have to think about going back here. So the x plus 6 squared is what's inside of parentheses here. And so if we take that times x, this is going to be a times, and x times that's going to be x cubed plus 12x squared plus 36x plus b times, well, this is just what was in parentheses up there, x squared plus 12x plus 36 plus c times, well, now we can just distribute here. That's x cubed plus 6x squared plus dx squared. All right, so we have all that. And so now I'm going to go get me another page, just a second. All right, and so now we have to simplify some more. So, well, let's go ahead and put this, oops. That's going to be our x cubed minus 5x squared plus 12x plus 144. And then again, x cubed plus, minus x cubed minus 5x squared plus 12x plus 144 equals. Now I'm going to distribute the a times that, so it's ax cubed plus 12ax squared plus 36ax plus, now we have bx squared plus 12bx plus 36b plus cx cubed plus 6cx squared plus dx squared. Okay, so we have a lot of stuff here. Now, what all do we have? Well, we have x cubed, and x cubed. Now we change letter colors. So we have an x squared, x squared, x squared, x squared, x squared. Let's change again. I don't know, blue maybe. Now we have x, x, x. Okay. And one last one. I don't know. Let's do green. Let's do the other green. And so we have a number, and that's all we have. All right, so I think we have everything. And so here we have a 1. So we get 1 equals, and then we have a plus c. Okay, so that's our first equation. Then we have a minus 5 equals, and then we have 12a plus b plus 6c plus d. Okay. And so I think that's everything there. So what about the next one, x's? So then we have 12 equals 36a plus 12b, and that looks good. And then we have just the numbers, 144 equals 36b. All right. So now let's transfer all of that to the next page. And so that said, that was 1 equals a plus c. Then we had, I think it was a negative 5 equals 12a plus b plus 6c plus d. Then we had 12 equals 36a plus 12b. And then our last one was 144 equals 36b. Okay. So the last one we can solve for b. So we can divide both sides by 36. And if we take this times 4, that's 24. And so it looks like b equals 4. Okay. So from that one, we can go plug that into here and get a. So 12 equals 36a plus 12 times 4. All right, so that's 48. So let's subtract 48. So here that's going to be a minus 36 equals 36a. So a is equal to a negative 1. Okay, so that looks good now. So guess what? We have the a, and so now we can solve for that c up here. And so we have 1 equals negative 1 plus c. And so if we add 1 to both sides, c is equal to 2. And now we have a, b, c, and we can solve for d. So minus 5 equals 12 times a, which was negative 1, plus b, which was originally 4, plus 6 times c, which is 2, and then plus d. So let's add up here. We have a negative 12 plus 4, then plus 12 plus d, and that's negative 5. Well, that 12 cancels that 12, so now we subtract 4, not 9. And so d is equal to a negative 9, it appears. Okay. And so now we have a, b, c, d, and so we can write our original fraction over. And so that was that long thing there. But if we just write just the last part over there, that's really the key part here. So we had a was a minus 1 over, and that was just x. And then b is 4, so then it was plus 4 over x squared. And then c is 2, so plus 2 over, and then that was x plus 6, I believe. And then plus d, which is 9, so it's a negative 9 over x plus 6 squared. Okay. And so that's going to be our partial fraction decomposition. So this was the most difficult one we've had up to this point. You know, we had 4 equations, 4 unknowns. Some of them came out really nice, so it really wasn't a lot of work in solving it. But that gives us then our total fraction partial fraction decomposition here. And again, this one is with the repeating factors in the denominator. All right, so that's into part 3, and I'll be back with part 4.